Okay, well, let's go back to the empirical rule. And what did the empirical rule say? The empirical rule said that if I'm 2 standard deviations away from the mean, then what percentage of that graph is underneath the curve? What percentage is 2 standard deviations away? Anybody remember? Two standard deviations. Okay, it should be 95%, right? 95%. Oh, sorry. Okay, so 2 standard deviations away is 95%. Okay, that goes back to the empirical rule. Okay, so is this going to be more than 95% or less than 95%? If we know that going from -2 to 2 is 95% of the area under the graph, then going from -2.76 to 1.96, is that going to be more than 95% or less than 95%? I mean, you don't have to be right. You can make a guess here. I mean, just make an educated guess. This is almost a 3, right? -2.76, that's almost a 3. So, okay, I would think it would include more area. So all the way here, more area. So if we get a number that's less than 95%, we know we did something wrong. Okay, it's always good to make an educated guess. Okay, and say, hey, you know what? Oh yeah, going back to the empirical rule, we had 95% here, and you know, so we should get an answer that's more than 95%, because this thing's almost at 3, and this thing is almost basically at 2. Okay, so let's use the table. We're going to get the table for 2.76, the table value for 2.76, and we're going to add that to the table value of 1.96. Okay, table value, the area from 0 to the 2.76 is below here, and the area from 0 to 1.96 is above. Okay. I'm having technical difficulties. I don't know why this thing is in. I need to go to full screen. There we go. Okay. Okay, so let's go to the table. Okay, so what would be 2.76 in my table? What would be 2.76 in my table? You guys have a table that you can look at? What would be the table value for 2.76? You go ahead and look that up. I've been doing too much of your work for you. You guys need to actively, I'm going to push you in the pool now. You need to actively start swimming around in this stuff. So what is the table value for 2.76? Okay, so 2.76 is 0.44 that right? 0.4, no, 0.49. Is it a 4 or a 9? Let me see. 2.76, right? 0.49. 0, 1, 2, 3, 4, 6, 7, yeah, 49711. Okay, 0.49711. Okay, what about 1.96? What's the table value for 1.96? Look it up in the table. Okay, so what was it? 1.96, 1.90, 1, 2, 3, 4, 6. Okay, I'm getting 0.47500. Okay, 0.47500. Okay, now what I'm going to do with those, I'm going to add up those two areas. Okay, so let's add those two areas up. I get 0.49711 plus 0.475 is 0.97211. Okay, so what's the probability? What's my probability here? Okay, yeah, 97.2% probability. Okay, a statistics instructor obtains heights of her 35 students. Luckily, the heights are normally distributed. Okay, with a mean of 64 inches, that's 5'4", and a standard deviation of 4.6 inches. What is the probability percentage for one of her students to have a height of 60 inches or more? Okay, so again, draw your diagram. Okay, what is the mean here? What is the mean? What's the average height in her class? Okay, thank you, Liliana. Yeah, 64. Okay, so 64. So where is 60 located? Where is 60 located? Is it to the right or to the left? Yeah, it's to the left. Okay, so 60 is lower than 64, right? So now what do I want? Do I want all the students that are less than 60, the tail, or do I want all of the ones that are more than 60? Yeah, I want all the ones that are more than 60. Okay. So now I got to look on my table and find out what is 60, right? No, what I made a mistake there. What was the mistake that I made? There's no 60 on my table. That's a problem, right? There's no 60 on my table. Oh, that's right, because I need a z-score. I can't. Z-scores go from 0 to 3. They don't go from 0 to 60. Okay. Okay. So we're going to say, oh, we need a z-score here. So how do we get a z-score? Z-score is x minus mu over sigma. What goes in for the x? What goes in for the x here? Okay.
60?
Yeah, 60 goes in for the x. What goes in for the mean? Mu.
64.
64.
64. What goes in for sigma?
4.6.
4.6. Okay, so we're going to divide that. 60 minus 64 divided by 4.6. Okay, whoops, I did that wrong. Order of operations. 60 minus 64 equals -4. Divide that by 4.6. Okay, is going to be negative 0.8695. I'm just going to, what can I call it? 0.8696. 8696. Okay, so negative 0.8696. Okay, so now I've got to look at my z-score table and get 0.8696. Okay, that's going to be 0. I'm able to put a 0 here. Negative 0. That's in the 0 row. 0.8696. Okay, so 0.8696. So let's go up to the 0.8, 0.8, and then 7, I guess, right? Because 696 is just going to be 7. So this is, I'm going to round this to 0.87. Okay, look in my table here. 0.8 is right here. 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7. I'm getting 0.3. I'm getting 0.30511. Is that right? 0.87. Nope, that's wrong. I miscounted. This is 0, 1, 2, 3, 4, 5, 6, and 7 is this guy here, 0.308. 30785. Okay, so that's 30785. So this has a z-score of negative 0.87, which tells me that the area between the median and this is going to be, what did we say it was? 0.30785. 0.30785. This is my table value. But I have to add this thing here, the 0.5, from the top half to that. 5. Okay, because the table value only gives me the distance from the z-score to the mean. It doesn't give me the whole thing. So this is going to be 0.807. I'm just going to put a 9 there. Okay, and so what is the probability percentage? Well, it's about 80.79%. So we would say that the probability of being 60 inches or more, 60 inches or more, x is greater than or equal to 60. Let me see this. X is greater than or equal to 60 is the same as saying the probability of the z-score being greater than or equal to negative 0.87, which is equal to 80.79%. Okay, or 80.8%. Okay, now we're going to go backwards. Here they give us the probability.
Sorry, I have a question. So going back to the last step you had, so you just, what's called, how do you get the, do you just make the decimal point into the percentage, and that's how you got the 80.72, right?
79. Yeah.
Oh, it's 79. Oh, okay. And I'm just a little still confused. Like for the 0.5, where does the 0.5 come from? Where you added the point 30?
If we go to the table,
Uh-huh.
the table only includes the numbers between 0. It doesn't include the extra stuff here. So if I wanted to include everything up to this value, I'd have to include half of the graph.
Mm-hmm.
And that half of the graph is 0.5.
Oh, okay.
So it depends on what you're looking for inside the graph. The table only gives me the area between 0 and whatever my z-score is.
Okay then. Thank you.
Okay, so let's see if we can go backwards here. We want to know what's the probability, okay, that z is greater than 0.9247. So once again, we're going to look at z is greater than, okay, z is greater than, z is greater than c, sorry, z is greater than c, okay, is equal to 0.9247. Well, it's got to be bigger than c. So I want to know, well, where am I going to put c? Is c going to be, is c going to be above the median or the mean, or is it going to be below, right? If it's above, I'm looking at a very small number, less than 0.5. If it's below, then it includes, everything plus this 0.5 piece. Okay, this half is included. So because this number is bigger than 0.5, I know that C has to be below the mean. Okay, it's got to be below the mean. Okay, so what I'm going to do is I'm going to take my 0.9247 and get 9247, and I'm going to subtract off this 0.5 so I can get a z-score. Okay, so that becomes 0.4247. Okay, and I'm going to look at my table and work backwards. So I'm going to say this is 0.42, 423, 425, 426, 0.427. So it's somewhere between this one and this one, and I have to kind of just choose whichever one's closest. Okay, so we have 0.42647. 0.42647. Okay. Oh, sorry, this is 0.4247. Not, I'm way off. 0.42. 0.4247. So it's not over here. It's over here. It's between these two. 0.42427. 0.4247. Let's see. Yeah, 0.4247. So it's between these two. And I just want to figure out which one's closer. Which one's relatively closer here? This is 0.42364. 0.42364. Okay. Okay, and the upper one is 0.42507. 0.42507. Okay, so which one is closer? We could do some subtraction and we could actually find out, well, how close they are. Okay, or we could just see, okay, this is 0.423, right? Think of them like maybe change the decimal. 6, 4, that's a 4. Okay, you could change the decimal if you really wanted to compare them. You'd be like, well, this is 42,364. This is 42,470. This is 42,005. Was that 07 or 67? 07. So 42,507. So which one is closer here? Okay, it looks like this thing is only about 37 units away, whereas this thing is more than that. It's like 106 units away. So this is 106 units away. So I'm going to go with this one here, okay, which is the 0.42507. So now I'm going to go back to the table and say, well, what was 0.42507? It was 1.401234. So 1.44. So that's 1.44. So 1.44. However, because C was less than the middle, and C is less than 0, this means it has a negative value. So C is equal to negative 1.44. Okay, that was my z-score that would produce this value here. Okay, that's going to produce. Okay, so if I went again, if I sum this all up and I said I want to go and check this, I would say, well, what's the z-score at negative 1.44? Negative 1.44. Well, that would be my table value for 1.44, which was 0.42507. 2507. 42507. Okay, and then I would add the 0.5 to that, which is the top half because we're going this direction. I want everything more, so plus 0.5. And then I would add those two together and I would get close to my result. Okay, for a standard normal distribution, okay, given z is greater than 0.79, find c. Okay, bonus, if mu is this and sigma is this, then find the value of x. Okay. So again, very similar to the problem we had before. We want to find c such that the area underneath here is 0.7983. So the first thing I need to do is subtract off 0.5. Okay, because our table is not going to give us the whole thing. We've got to subtract off this half minus the top half, minus 0.5. Those are going to be 0.2983. Now I'm going to look at my table and work backwards to find my z-score. Z is equal to what? So 0.2983. Okay, 0.2983. 0.29, oh, look at this, 0.2983. Looks like it's going to be closer. It's in this row here. Okay, so we've got 0.296 and 0.299. Okay, so we want 83, right? 83. That's 14 away, or 12 away. That's 12 away there. And 83, that's, how far away is that? That is, what is it? 16. So 16 away there and 12 away here. So I'm going to go with this guy. So that's 0, 1, 2, 3, 4. So that's 0.84. Okay. So 0.84, z is equal to, and once again, it's below 0. Okay, it's on the left side, so this is negative 0.84. So z is equal to negative 0.84. So the bonus says, find the value of x. Well, how do we get x? We're going to do the z-score in reverse. Okay, we're going to plug in what we know. Well, what do I know? What do we know? We know that z is 0.298, sorry. Z is negative 0.84. And x is what I'm looking for. Mu is 9.244. And sigma is 0.9. So multiply both sides by 0.9. And we get 0.9 times 0.84. Okay, what's 0.9 times 0.84? 0.9 times 0.84 is 0.756. This is negative 0.756 is equal to x minus 9.244. Okay, so I'm going to add 9.244 to both sides. And I get x is equal to, when I do 9.244 minus 0.756, I get 8.488, and that's my x value. Okay. Okay, let's do a couple of examples with this. Newfound understanding. Okay, suppose that a wrapper of a certain candy bar lists its weight as 2.13 ounces. Naturally, the weight of the individual bars varies somewhat. Suppose the weights of these candy bars vary according to a normal distribution with a mu of 2.2 and standard deviation of 4. What proportion of the candy bar weighs less than the advertised weight? Well, its list weight is 2.13, right? So they're saying, look, we have this normal distribution, which kind of sucks. Okay, and we have a mean of what? What's the mean here? What's the mean of the candy bar?
.13.
What does mu mean? I mean, the answer is in the question. Okay, mu is the mean. Sigma is the standard deviation. Okay. It's actually the mean of the population. So X bar is the mean of the sample. I don't know why there's lag. Let's stop my sharing for a second. Okay, so the mean is 2.2. Okay, and where is 2.13? Well, it's less than 2.2. So let's just put it less than 2.2. 2.13. Okay, so now it says, what proportion of the candy bars weigh less than the advertised weight? Weigh less than the advertised weight. So we want this area here. Okay, the tail. And to find the tail, that's 0.5 minus the table value. But the table value of what? The table value of the z-score. We've got to find the z-score first. So the z-score is going to be equal to x minus mu over sigma. X in this case is 2.13 minus mu, which is 2.2, all over sigma, which is 0.04. Okay, plug that into a calculator. stop with the sharing. There we go. Better. Okay, so 2.13 minus 2.2 over 0.04. Okay, so when I plug that into my calculator, 2.13 minus 2.2 divided by 0.04, I get negative 1.75. So this is negative 1.75. So I want to know, okay, what's the area, the probability, proportion, that it weighs less than 2.3. So this would be x is less than 2.13 is the same as the proportion that z is less than negative 1.75. Okay, and that's going to be equal to 0.5 minus the table value for 1.75. So let's go to the table value of 1.75. Okay, so the table value of this is 0, 1, 2, 3, 4, 5. 1.75 is this one there. So it's 0.45994. 0.45994. Okay, so if I were to subtract that, 0.5 minus 0.45994, I would get basically 0.04, okay, or 4%. 0.040, okay, or move the decimal over, I get 4%. So there's a 4% chance, okay, that the candy bar, and you're gonna want to write that out, okay. There is, what is this 4% reference? You know, this is a word problem. You got to have words in your answer. Okay, this is not your answer. Your answer is there is a 4% chance of selecting a candy bar that does what? What are we testing here? Candy bar that weighs less than the advertised weight. Okay, boom, now you're done. Okay, what proportion of candy bars is between 2.2 and 2.3? Okay, what proportion of candy bars? Well, what was the mean? The mean was 2.2, right? Okay, so that's the mean. The mean is 2.2. And we want to know what lies between 2.2 and 2.3. Well, if the mean is 2.2, if the z-score, how do I know that the mean is, that the z-score, that the mean is in the middle here, the 2.2 is in the middle? Well, if you did a z-score here of 2.2, you get 2.2 minus 2.2 all over sigma, which is 0 over sigma, which is 0. So yeah, 2.2 is the 0 z-score. Okay, what's 2.3? 2.3 minus 2.2 all over 0.04. Okay, this is going to be 0.1 over 0.04. Okay, which I think ends up being 2.5. Okay, so now I have to go and see, well, what's my table value for 2.5? Okay. Table value for 2.5. 2.5 is 0. Is this guy there, 0.49379? So 0.49379. Okay, what's the proportion though? We want the proportion of the probability that we're going to get between 2.2 and 2.3, which is the same as saying what's the probability of going from 0 to z to 2.5. And according to the table, that was 0.49379, which if we round, if we change it to a percentage and round, we would get 49.4%. Okay, the Acme manufactures widgets. The distribution of widget weights is bell-shaped. The widgets weights have a mean of 51 and a standard deviation of 4. Okay. Use the empirical rule to answer the following questions. Oh, okay, empirical rule. Okay, I like the empirical rule. 99.7% lie between what two weights? Well, I know that 99.7% lie between how many standard deviations? How many standard deviations have 99.7% of the graph? Any ideas? Go back and review the empirical rule. How many standard deviations give me 99.7%? Okay, yeah, 3. So it's -3 to +3, right? -3 to +3. So I know that, okay. So I know that the probability that z goes from -3, okay, standard deviations, to +3 standard deviations is 99.7%. Okay, so how does that help me here? Well, what was the mean? The mean would be at 0, but what is the mean? The mean is 51, right? 51. What is one standard deviation above the mean? Oh, wouldn't I just add 3 to that? Wouldn't that be 54? And then what would the second one be? Wouldn't that, I just add 3 to that? Wouldn't that be 57? And then wouldn't I just go to 60 here? Right, so the probability that X is less than 60. Okay, and you can, doesn't that make sense that if I took,
Do we not use 4? Because it says the standard deviation of 4 ounces.
oh, am I adding, sorry, you're right. Yeah, I should be adding 4, my bad. 55, 59, and 63, right? Okay. So this is going to go to 63. Okay. And so what if I went lower? What if I subtracted? I would be at what, 42? Something like that? No. I would be at 30. What would I be at? 39. Yeah, 39. Yeah, 39. So this is 39 if I kept going down. I could easily do that by saying, well, what's 51 plus 3 times 4 standard deviations? 3 standard deviations. That's 51 plus 12, which is 63. And what's 51 minus 3 standard deviations? 51 minus 12, which is 39. Okay, so 39 to 63. Okay, and so it says to answer 99% of the widgets lie between what two weights? Well, 39 ounces, these are ounces, and 63 ounces. So is 99.7%. So between 39 and 63 ounces. Okay. Part B, what percentage of the widget lies between 54 43 and 63. Okay, so 43. So again, using the empirical rule. So what's 2 and 3? 3 was 39, and this is, let's keep going here. This was 51, 55. So this is plus 1, plus 2, plus 3. Okay, this is 59 and 63. So this is minus 1, minus 2, minus 3 was 39. Okay, 51 minus 4 is 47. Minus 4 again is 43. Okay, so we want to know what percentage is between 43 and 63. Well, to go up to 63 would be 3 standard deviations. Okay, so that's half of 99.7. So that's this guy here. Oops. This guy here is going to be 1/2 of 0.997. That's that shaded yellow. Okay, the shaded green is only going to go down to 2. Okay, and so what's that? Well, that's 1/2 of 95. Okay, so this guy over here is 1/2 of 0.95. That's 1/2 of 95% because that goes down to 2. So it's just the lower half. Okay, which is going to be 47.5. So this is 47.5%. Okay, and what's half of 99.7? That's 49.85%. This is 49.85%. If we add those two together, we get 97.35%. So 47.5% plus 49.85% is 97.35%. Okay, so that's what that one is. Okay, and what percentage of the widget lies below 47? Okay, lies below 1 standard deviation. So once again, we have this guy here. What percentage? Okay, so 47 was at one standard deviation. We want to know what percentage lies below one standard deviation. It's asking me to use the empirical rule. I probably wouldn't even want to use the empirical rule. I'd probably just go into using the table on this one.
All right, Professor. Wait, did you add up 47.5 plus 44.85?
49.85.
Sorry, 49. Okay, thank you.
So this is the green one, green area. This is the yellow area. Okay, so again, it says use the empirical rule here. Third question. Okay, so we're going to say what's less than 1? Well, the problem is that we need to look at the mean here, okay? And we need to look at, well, what is this area? What's not? What's the not area, basically, right? So you got to kind of think about this for a second. So between 1 and -1 for the empirical rule, okay, between 1 and -1 is 68%. So in here is 68% of the graph. If I were to cut that in half, okay, between 1 and -1, so 68% divided by 2 is 34%. So this in here, let me get rid of that. Okay, so this piece here, let me put it in a different color. Okay, this piece right here, Okay, this lemon lime piece here is 34% of the graph. So what would be the red part? If this green part is 34%, this whole half is 50%. Okay, then 50% minus 34% is going to equal 'Kay. You know what, this should be plus, I'm sorry. This should be 50% plus this thing, but anyway, this is 34% plus, because it says lies above this. I read it wrong. We're not looking for this piece. We're looking for this as well. Okay, looking for that piece, this plus this whole thing. So this really just is 34% plus this additional 50%. This is the 50% that I'm looking at. I want to add those two. So that's 84%. Okay. So just know that half of this thing is 34%. And then the rest of this above it. Okay, because we want everything above 47. Okay. Okay, and that's it for chapter 11. So since we're all caught up, we will have no class on Wednesday. Class will be canceled on Wednesday.
We have a test next week, right?
You have a what?
We have a test next week.
Yes,
A test.
on chapters.
Okay. If we need a study,
The study,
10 and 11.
the study guide.
No, if we need any help, we just send you an email, like a study session or tutoring with the exam review.
Well, yeah, we can go over it on Monday as well.
Oh, okay. Just wanted to make sure. Thank you.
No, there's no class on Wednesday. Class is canceled Wednesday. Okay, no class on Wednesday.